Hello, everyone. Some of you might know Siemens was founded 1847, and that's why we have the next 47 investment company part of the Siemens. And from time to time, people from Next 47 are reaching out. Hey, Roger, we have here and here a company we're looking at, or that's a nice opportunity. Of a new investment and explaining the things. So last year we had from Apollo colleague Andy Roberts, showing us and introducing us to GraphQL. And now I'm really happy to have Antonio here giving us an introduction on Bazel.
Hi everybody. Thank you. First of all, I just wanted to say, like, been in Switzerland a few days now. It's quite beautiful, lovely place. Bit too many trees and cows, but we can work on that. And who am I? No, what's the wrong slide? Who am I? Someone that does not know how to use slides. Oh, now it works. So I'm Antonio Di Stefano. I'm a DevX engineer at EngFlow. You might ask, what is DevX? So if you remember the last tech talk that you just received, the term DevOps is really overcrowded. So we made it even worse and added a new term to make things even more confusing. And DevX is someone who works in the software delivery part of DevOps and makes the processes, the workflows from code to production faster and easier. We basically make a developer's life easier, except ours, because we like pain. And specifically, I work on the build part of development experience, which is absolutely the most boring one, which is why I love it so much, because there's like a lot that we can do to make it better. So back to the previous slide, because I don't know how to order things. So what is this talk about? I'm going to introduce you to the concept of build system. You're probably familiar with it. But it's a good refresher. I want to understand what are the things that we really care about in a build system, and how other build systems implement them, and why you should care about this build system that I'm going to introduce you to, which is called Bazel. So a short history of them, what challenges they face, and then I'm going to introduce you to my beloved Bazel. And hopefully you're going to like that too. So what is a build system? So a build system is kind of like this magical tool that takes what you write and actually makes it work sometimes. Mileage may vary. So it takes your code, it compiles it, but it can also be used to generate code without any copyright, apparently. Again, I'm not your lawyer either, so maybe you want to ask that one. It also runs tests, and at the end, it helps you package things so that you can, throw them somewhere. It's the yeet part of the build process. And so with that come a few challenges. Developers don't really want to sit there and wait 1 hour, 2 hours, or maybe even 4 hours if you're working on, what's the name, that project? Knative. So, yeah, thanks. You don't want to wait 4 hours because that's half of your workday. It's a lot of time to get breaks. Kind of like that, actually. So you want something that is fast, takes your code, runs it, and it doesn't take too much time to get that feedback, right? You also want something that works somewhat reliably, is reproducible. So if you run the same build, you run it twice, you expect the same result, don't you? Sometimes you don't, and you have to run clean. And then you have to wait even more, because you've just cleaned everything. And so you want something that is reproducible. And sometimes you also want something that is really, really, really configurable. Some of you work on like very esoteric platforms. Some of you work on web stuff, and sometimes you share things. And you want to be able to go from one to the other. You also want to make things really, really configurable, depending on what you need for that specific build. And one thing that helps in this regard is to make sure that your build system is really extendable. So maybe you work with C and C++, but maybe you also have some JavaScript, sadly, or Java, bit better. And it is really, really paramount in a big organization to be able to support multiple build systems or multiple tools. Like, if you work in a big enough organization, there's always that small tool that is fundamental to deploy something, and you are the only ones using it. And so you have to be able to integrate that within your build system and somehow make that scale. And last but not least, it's the integrations that exist out of the box. So how well does your build system integrate within the IDEs, CLI tools, and so on? Because at the end of the day, the build system is what drives most of the integrations, right? You have a CMake project, you import it somewhere, it's supposed to show everything you're expecting to do, like showing symbols, showing your source code, correctly understanding where the source code is, and correctly picking up tests, right? You expect that. And so integrations is probably one of the most important parts of the build system, even though it does not belong to the build system itself. A short history of build systems. So the first historical build system, also called Knative build system, is lots of shell scripting, lots of it. And it looks reasonable enough at a first glance. There's a bunch of problems with it. First of all, like, you gotta write all this stuff yourself. You can simplify. We could export a few environment variables here, a few functions, make it easier. But even at the first glance, there's a few problems, right? Well, first, there is a good side of, like, you're gonna stay in that company forever. Like, nobody's gonna fire you because the only one that actually understands that build script. So job stability, big plus. And you can kind of use it everywhere with anything, right? It's just shell script. I don't know where you can't run it. Well, hopefully in a reasonable repo. But it's not very portable. Try to run it on Windows, and you're going to find out the hard way that it's not very portable. It requires a lot of setup for each workstation. So you need to install all the tooling. You're going to have to spend time doing that. And maybe like you get one version wrong of a single compiler, and nothing works. And you spend the next 5 days figuring out what that is, because it's not declared as part of the system, right? There is no caching. Like, no way that there's any caching at all. Nothing. So if you change anything, pretty much everything else is going to change. It's just not a build system, so you don't really get those properties that most build systems have. It's hard to parallelize and speed up, right? You may just think, you at the end of each of these lines. But then what happens is, like if there are dependencies, for example, main and test depend from lib, you could run main and test at the same time, but you have to wire that knowledge inside the script, right? You can't just run all 3 of them at the same time. And if the dependencies change, you need to also reconfigure the build so that things run parallelly the way you expect them to, because dependencies may break that parallelism. So you need to wire that knowledge inside the build script. And that's knowledge that changes over time. You change your build, you add a new dependency, you have to include a new file. This changes completely. And it's hard to figure out what changed exactly. It's also a bespoke configuration. Everybody can do it the way they want it. So you get on a new repository, same company maybe. Nothing works the same way. It's all different. Like, they made their new thing because they thought, like, build tool 2.0 was cooler than build 2.1. So why not? Most importantly, absolutely zero configuration. Like, you don't get anything out of the box except therapy sessions. And even more, you can't say, I want to target this specific part of the build. You always have to run everything, because you can't separate build targets within a shell script, unless you really want to over-engineer the shell script. So if you say you want to build just a small part of the project, just a small library to test it, that is really hard to do if you don't have a proper build system and you're just using shell scripts. So this is definitely something we don't want to do. It happens in the wild rather than as a build system, more as a way to integrate various build systems. And so like with Knative, it's not the main build system, but it connects multiple repos together. So that is more acceptable than having the whole build on shell scripts. But still, we can do better than that. And so Make came, and they did quite a few cool things. It's a bit easier to configure. Targets are explicit. And you have dependencies between targets, right? So now this build has the knowledge necessary to say, lib we have to run before main and before test, but we can run main and test in parallel. So now your build is already faster because you can do that. It's also easier to edit, because if you want to add a new dependency, you just add a new dependency here, and it can compute the build graph and run things the way they're supposed to run, in the order they're supposed to run. And it does allow you to configure custom targets the same way. So it's all right. It's an improvement, but it's just a small improvement. It is, of course, able to cache build targets, which is an interesting property we now have. So if you've done work, you don't have to redo work. You can parallelize things. And it is somewhat integrated with other platforms, but not that great. And you can use it with anything, really. As long as you can use a tool like GCC, Java, whatever, you can use it. So it can be used with multiple languages. It can be integrated with multiple platforms somewhat transparently. It's pretty much as portable as a shell script. It's a glorified shell script, really. And the caching is actually, though it is present, is quite naive. It's based on the timestamp, on the update timestamp. So if you change that, it's going to rebuild everything that depends on that. Whereas, really, if the content of that didn't change, then you really don't want to rebuild it either. So timestamp works, but it's rather naive. And it's really hard to reuse tooling. So if you look at this, it's not that abstract in saying, I want to compile this C++ file, right? There's not too much of an abstraction. It's just invoke the C++ compiler. And so it gets hard to maintain as time goes by. It's really hard to read. Like, I've seen some make files in the wild that are like thousands of lines or more, like bigger than the code base that they're supposed to build. And so it's all right, but we can do better than this, right? And CMake comes in the picture. CMake doesn't actually build anything itself, ish. Can still generate code and invalidate copyrights, so that it can do that. But CMake, what it does, it's going to generate a build script based on a higher level configuration, which also offers a chance for reusability. So CMake's got macros, it's got functions, and so you can reuse those rather than having to rewrite, hey, I want to invoke GCC with this flags and so on and so on. You can reuse bits. It's also going to embed some best practices with some really high-level defined targets, make them configurable as if you were in the build system you're going to target. At the end of the day, though, the build is still executed by the build system downstream, which could be Make, could be Ninja, hopefully Ninja. But it's still another build system that is executing the build. It is still a big step ahead. It's way more readable, way more reusable, and also way more concise, honestly. So you get the reusability. It's easier to write. It's also way better within different platforms, so it's way more portable because it does some magic on the final build itself, and you don't have to think about it. It's got great, honestly, great support for some compiled languages and for tooling. Like the tooling that you get with CMake is way better than what you got with the two before, and also way better than what you're going to get with Bazel, just to be clear. That's a disclaimer. It's very configurable, and someone actually wrote a ray tracer with CMake, I found out recently. Hi, Damien. But it still suffered from the same issue as the previous build system, because at the end of the day, you're not running CMake to run the build. You're still running either Make or Ninja. So it suffers from all the same problems. It is better, but it suffers from the same problems. And it's worth mentioning that they're not the only 3 build systems. Pretty much every language has its own build system at this point. Some have 2. Thank you, Java. Or more. Thank you, Java. And now we're going to talk about this one specifically, which is Maven, the one that I detest the most. Declarative build script. You supply dependencies. You give it a few properties. You define the coordinates of the artifact. Very readable, honestly. Though it's XML, still very readable. But it's really hard to configure. And one of the problems that these build systems usually have is that though they make everything look like magic, they just work. You drop the file, it just works, kind of. They are hard to improve, right? So with Maven in Java projects, you're just going to get big compilation units, no matter what you do, because you're not in control of it. And so it's hard to improve performances with this kind of build systems usually. And same for other language-specific build systems. And so, you know, it's got some nice properties. You drop it in. It's easy to use. It works with your tooling. Technique is the thing that works best with the tooling. Like, your IDE is probably going to integrate with Maven rather than a generic build system that works with multiple languages. It's easier. It's got better facilities for the specific language. And it's often the standard, right? The standard for Java is sadly Maven. So it just works. And so those are the advantages now. There's a bunch of disadvantages. You need a specific build system for every single language. So every time you introduce a new language, you add additional complexity, and you need a bunch of shell script to coordinate multiple builds if you want to join them in some way. It's really hard to tune, which we just talked about. You don't have that level of granularity you have with different build systems like Maven, what did I just say? With Make, with CMake, and so on. You don't get that level of granularity, so you can't tune it too much. You can't say I want a smaller compilation unit, or I want multiple smaller compilation units that I can parallelize and thus improve performances. You can't say that. So if you change one file in a module in Maven, it's going to rebuild everything. I just added one line on one file. It's going to rebuild the whole damn project. And that's what you get if you use Maven, which you shouldn't. You shouldn't. All right? So now we get into the juicy stuff, my kind of kink, which is Bazel. So Bazel is this super weird and powerful and beautiful and magical and weird, really weird, build system developed by Google. Now, why does something like this come from Google? Well, Google's got a really interesting problem. They have a lot of code, like a lot of code. Like they're thinking about millions of files, not thousands. They're thinking about billions of lines of code. And they have everything in a single repo. They have a huge monorepo with everything in it. When you try to build that, problems arise, a lot of them. And so they developed this really scalable build system called Bazel. Actually, internally, it's called Blaze. And it's not really the same thing. They share most things. They share a common core. But really, Bazel is a slightly different thing. Bazel. What? Just merge them. Blaze and Bazel, sorry for that. And it's designed to run at that scale. So once you hit that certain limit, you want something like Bazel that scales up to that. And it's focusing on that. Big projects, big repositories, monorepos. And the main reason why it does that is because Bazel is really correct. Bazel focuses on correctness more than anything else. You're not going to run Bazel clean. You're almost never going to run Bazel clean. Apparently, if you upgrade big Xcode, you're going to have to run Bazel clean. There's actually a flag to say Bazel clean, but clean harder. And that's what you need to run when you upgrade Xcode, which is great. Love Mac. But aside from that, you rarely have to clean a build. So that means that you're mostly going to get incremental builds all the time, unless you change something that is used by everything else, in which case it's on you, really. It's on you. It's very extendable. It's the language that it uses to be extended is called Starlark, and it's a Pythonish-like language, but crippled. It's Python, but it couldn't quite make it. So it doesn't have like unbounded loops, doesn't have classes, doesn't have a bunch of features, doesn't have recursion. And all of these are features that have actually been removed for the sake of determinism. So the focus is that when you run Bazel build, you're always going to know all the things that you're going to build, all your targets in a deterministic way. All the actions that you need to run, all the commands, and you know which ones have changed, because it's fully declaring its inputs. You know that all the actions are running in a sandbox, so they're well isolated. They can't look at the system. So theoretically, if you run the same thing twice, it's going to return the same thing because it's sandboxed and it's fully declarative. You can't have an action that sometimes works in a way and sometimes in the other. So with this single property, you have this magical feature, which is now if the content of the files in the inputs of these actions have not changed, then of course the result is going to be always the same in theory. Now, you can break that. You can really break that. I got to the point of running Snake in Bazel, which is great. Funniest thing I've ever done. So because you have this correctness, now speed follows this correctness, right? You don't have to rerun the same thing twice, so it's faster. You have to do less work. is fully declarative. It allows you to define very granular targets, so you can really parallelize the build, because now you can run lots of things at the same time, right? It's really good at detecting what changed and what not. So you do the least amount of work in a really parallelized fashion, and you can do it, really, with pretty much any programming language. Right? Think about random language. Come on, give me a language. Ruby. Ruby is supported by Bazel. Rules Ruby. Another language?
PHP.
I want to say that it's probably supported, but I hope not. Next one. I want someone less controversial. Fortran I know is supported. There is a rule set for Fortran. I also don't want to find out about COBOL, honestly. Probably. You have C, you have all the .NET goodies, you have Java. Huh? Dart. Though it comes from Google as well, it's probably like the least supported one. There is a rule set for it. It's open source, but it's meh. Rust, you've got Kotlin, Scala, JavaScript, whatever you can think of pretty much, except it's like Fortran and PHP, I think. No, Fortran and COBOL and PHP. Those may even be supported, but I really don't want to find out. And of course, the coolest feature, which is why I actually have a salary, and why I was called here, is the built-in caching and distributed builds for faster, and it's very repetitive. Basically, Bazel can cache really well, can cache remotely, and can even run builds remotely at the most granular level, which is the action itself, right? And so that's actually what my company does. At EngFlow, we have this with this big engine that allows you to horizontally scale your builds, right? So instead of running a build with a level of parallelism of 16 or 32, because that's the number of cores you have, you can think about want to run a build with the level of parallelism of 200. The build is going to be much faster. You're going to get cache hits from your colleagues and your CI. And overall, you can get like a 4 hours build down to half an hour or even better. So that's what we do. We do distributed caching and execution for builds in Bazel. The protocol we use is not only supported by Bazel, but for the sake of this talk, we're going to focus on it. So you also get out of the box this ability to run builds in a distributed fashion. So your company can just buy a big cluster of cores, and those cores can be magically used by everybody. You also get the same caches, and that's pretty great, because now like, everybody has to build less code, really. Well, let's have a look. It's actually pretty easy to understand if you think about it, right? We've declared a library, which we had before. We've also declared a binary that we're going to run, our main, and we've declared a test. To build, we use the build command, and we're going to say build main. And to test it, we can use the Bazel test command. And also, great thing, tests are also actions, so we can also distribute tests remotely. So tests are really slow, probably the slowest part of any build. And so instead of running 16 tests at a time, you can run a few hundred. And if you're spinning up a whole Kubernetes cluster, maybe that's really useful. And so the syntax is a bit different, but it's not too different. It's somewhat familiar. At the end of the day, we all played with Python a bit. And the concepts really are very similar to those of other build systems. So those are like the reasons why I think it's a good idea to use Bazel. So if you have a huge repository, if you're using multiple programming languages at the same time, you want to coordinate things, or like you have a lot of tests and they're slow, then Bazel might be a good idea, because it's really good at these three things. It's very extendable. It's probably already been extended for your programming language, unless you really want to code in PHP. And I had another point, but I forgot it. So there's that. And it's still somewhat understandable. The integrations with the tooling are not perfect, but they're getting better and better over time. It's an open source project. It's growing and growing constantly. And new features are popping up with every single version. Like, I work with them every single day, yet I lose track of them. So it's an ever-growing build system. It's getting better and better by the day. So it's worth checking out if you have like builds you want to speed up. It scales much better than pretty much all the others. Well, I should have shown this slide. And this is pretty much a summary of what I said. Like, the only problem that I do really see is it can be quite intimidating at the beginning, because it does things a bit differently from other build systems, right? Like, sources and build tree are completely separate. Sandboxing is quite a different concept from other build systems. The extension language being limited this way can also be quite of a challenge. But at the same time, it's backed by some tech giants like Google, Uber, Dropbox, and SpaceX. And they've all done it because they saw builds scale really poorly. They saw their builds getting slower and slower and become hours and hours to get a product from code to production. So let's look at things a bit more in depth, because we still have time. So I'm going to introduce a few Bazel concepts. Some of them are quite weird, but most of them should feel familiar. So first concept is a target. A target is a build target, like in any other language. So it's something that has 0 or more input files, 0 or more output files, and 0 or more generating actions. Right? It could also just return some metadata. I'm not going to explore that, but it's something that takes an input, runs something, and from that something gives you an output. Same build target as any other programming language, same as any other build system. Same with Make, you see it with CMake. You kind of saw it with shells, kind of. You definitely didn't see that with Maven because it's hidden behind the hood. But those targets are not the most granular execution unit. That is the action. So an action is literally a single command. Like run GCC, run javac, run a test. So that is an action, the most granular thing. Actually, one of the reasons why Bazel scales so well is that there is this additional level of granularity. So when you run builds remotely, for example, it's not going to execute the whole target, which could be multiple actions at the same time. It's going to run each action individually. So the build graph is built at a higher level of granularity than most of the languages, build systems. This is quite the interesting concept. Bazel has this concept of workspace. And the workspace, you can think of it as a repo. Like your repo containing the code, that is a workspace. Other dependencies that have code that you import, those are other workspaces. And a workspace is demarked by the existence of this file, right? Workspace. So for example, this B directory has another workspace file in it, which makes it a separate workspace. And actually from A, you won't be able to see B unless you import it as a workspace. And it's basically just a container of files. It's the root of your build in a way. And once again, there's a deeper concept, more granular concept, which is called packages. And a package is basically a directory which contains a file called the build file. And the build file is where you place your build definitions. So you can have more granular targets on that specific package and reuse them somewhere else. You can also apply some visibility conditions. So you can say, I have this library, but this library can only be used by project A, B, and C, not by D. And so it can isolate build targets, can give them different visibility. Can also be, and it can be used to basically localize all kind of build actions, right? But then you need to be able to reference those things. And the way you do that in Bazel is a label, which is a string, but it's not quite a string. It's very confusing. It follows the syntax where you have the workspace name, /, package name, and then the target name. Now, some of these things are optional. I don't even remember which ones are. It's a bit confusing. So like, if the workspace is the main workspace, your current repository, I don't necessarily need it here. Or you can just call it @. Package name within the same package, actually optional. And you can just have the target name. The target name is always present. Actually, no. If the package name is the same as the target name, you can omit it. So it is a bit of a weird syntax. If you just go with the full express one, that also works. And it's how you identify build targets. And those are source files within a build in Bazel. Right? So that's what a Bazel is, what a label is in Bazel. It's just a reference to a build target or a source file. Now, we've already talked about build files. In build files, you can have two different things. You can either instantiate macros or you can instantiate rules, which is somewhat similar to the equivalent concept in CMake I just explained. So macros are going to be expanded to different targets, and rules are how you define completely custom logic. So this is how you define a rule. See the Python-like syntax? You have a function which takes a context, and you can write strings on it. You can also execute commands. And when you declare the rule, you say, hey, it's implemented by this function. It's got these attributes. And it's got these outputs. So that's how you declare a rule. On the other end, a macro is a bit simpler. And it's just basically a Python function where you can add other targets, right? So you can have a parameterized CC library that feeds into a CC binary. And they're all done in one shot, because then the macro expands to both targets, right? So macros are definitely like one of the most useful tools that you get when you're starting to use Bazel, because they're not really hard to comprehend. They're just Python functions. But they're actually quite powerful, right? Because there are already rules predefined for most languages. So most of the times, you don't need to go with the completely custom logic of rules. You're probably just fine creating a macro. There's utility libraries. There is anything really that you can use. So oftentimes, just creating a macro is enough to extend your build. In fact, I'd suggest looking at macros first before you implement your own custom rule, because custom rules can get really hard to comprehend and to change, whereas macros are relatively easy. Now, onto the weirdest bit. Bazel's got a lot of flags. Like, I'm talking about hundreds of flags. It's how Bazel is configured. It's the weirdest thing. Google loves flags everywhere. And so to have complex configurations, they came up with this file format, which I really dislike. And it's called the Bazel RC. So it basically allows you to say, for this stage, in this case build, I want to expand these flags always. Or you can group them and say, when I'm running in CI, I want these flags. When I'm running with remote build execution, I want this other flag, which is how you say, I want to run something remotely. And then you can say, Bazel build with this configuration, or just this or this. It's a bit confusing, but it's basically this file at the root of the project, which allows you to define groups of flags or flags that are always necessary for a build to work. I really don't like it, but it's how you configure, you create reusable configurations in Bazel. Now, I said multiple times that one of the most important things for a build system is how it integrates with third-party tools. And there's quite a few really good ones that you can use to simplify your workflow or migrate to Bazel if you want to. And I'm going to list a few that I really, really love. So Bazel is probably my favorite one. It's an automatic build generator. It generates the build files for you for certain languages. The best supported one is Go. So if you're using Go, you probably will never have to write a build file with Bazel. Maybe, probably, I don't know. You don't have to write as much build files, almost nothing at all. And that is one great thing, because one of the problems working with Bazel is that you got to write somewhat complex build files, right? To get those nice properties that Bazel has, you got to write those build files, whereas Bazel just looks at the Go source files and figures out, OK, you have these dependencies between these various projects. I can update them for you as well. And so you don't have to do that manually. Another tool I really like is Buildozer. I like to think of it as a really powerful sed for Bazel. It allows you to just to say, I want to change this attribute for all the targets that are like Java, or even more complex rules. So it's a tool that allows you to rewrite a whole build for a whole project in a few simple commands. Really powerful, bit hard to comprehend, but it's just amazing for major refactorings. Right? You're like, for example, you're introducing a new library that replaces a legacy version, and you're using that library in 1,000 places, right? With just one command, you can replace it everywhere. So that is a pretty powerful tool. Basilisk, it's the de facto version manager for Bazel. I've never manually installed Bazel myself, because I just use Basilisk. I define the version, and Basilisk does it for myself. Now, that is really important, because Bazel versions change a lot. So like, if you go from 5.x to 6, lots of things might not even work. So having a stable version in a project is really, really important. If you're familiar with Gradle, they have the same problem. There's Gradle version and Gradle U. Basilisk is the Gradle U of Bazel. A tool that I also really like is Exodus, and I like it because it allows you to migrate away from Maven, which is one of humanity's greatest mistakes. It's great. They've done a great work. It really works. You just run it. It magically works. Great. And you can find a lot more tools if you go to awesomebazels.com. There's a plethora, like all the languages that you support, the rule sets, so groups of rules that implement those languages, and so on, other tools, anything, even resources for learning. So the community is growing, more projects are popping up, the system is getting better and better, and it's really what you need if you have a huge build that is getting unwieldy, or if you want to coordinate builds within multiple projects, within multiple programming languages, or you want to get better caching or remote execution. It's a really powerful build system. It comes with a bit of complexity, but that is getting better and better as time goes, thanks to this amazing tooling. Now, thank you a lot, and if you have any questions, please ask them or no.
Okay, thank you very much for your presentation. What I would be interested in, you compared it to so many other solutions, and I was wondering, how do you compare Bazel to Bug or Bug 2?
Yeah, Bug 2 is great. No, they're very similar. Like conceptually, Bug 2, Pants, Please Build, Bazel, they do the same thing. They're all great. I've been using multiple ones of them. I mostly use Bazel because that's what we use at work. Most of our company comes from a Bazel background. Our CTO is one of the main developers of Bazel. He's working for 10 years. And it's also like the most widely supported. It's got just more tools and so on. I'm really interested in Bug 2 and also and Pants 2. Pants 2 because the premise is that you're not going to have to write as many build files. It's going to try to be smart about it. And also the extension language is just Python. And I'm not the biggest fan of a limited language like Starlark. It does introduce some nice properties, but maybe they're not worth the loss in user experience for us developers that it has. So I'm really excited for the idea that Pants is introducing. Bug 2 I'm really curious about. I want to see how it evolves. Planning to test it much more sooner. So, great question. They're all great. That's the catch. And if you're using PHP, probably Bug is better. Just don't.
Yeah, so every tool has its limits in the sense how you're using it. So we also had some experience with Bazel, which I'm not sure, as I didn't dig too deep into it, too much to blame the package we want to build that way, and too much to blame Bazel for that. So in short, it's TensorFlow, which is a Google thing as well, and it's a horrible mess to reproduce that and rebuild that. And part of that actually was that it's vendored, so Bazel is used to pull all the dependencies and rebuild them from source, rather than being configurable, easily configurable to choose the dependencies from pre-built sources or from pre-packaged sources. So is this a limitation of Bazel, that it makes it too hard to switch from a rebuild to just pick up what is there and to switch to offline build reliably, or is this something which is more to blame how it was used nicely in TensorFlow?
It's how it was used. you can change the way that you're pulling dependencies. There's multiple mechanisms. You can pull sources and build them. You can pull pre-built artifacts. We at EngFlow use a mix of that. In some cases, it makes sense to vendor sources. In some cases, I really don't want to recompile that. Why would I? So I'm just going to pull the binary artifact. So it's really up to the build engineers or the developers writing the build. Yeah, I'm sad to hear that, because it really depends on how people use it.
I have a question to the caching. We have several build systems that do some caching, but we would like to run various projects on it. And they're separate projects. They have a core which is proprietary, and the rest is basically open source. So we'd like to have something like the open source stuff is shared in a big cache, and then you have the proprietary stuff which should be separated. Can you handle that in Bazel somehow with access rights to your cache?
Bazel probably can, but because it's not really up to Bazel. It's up to the remote execution, remote caching engine to be able to detect those things. I don't think we support it yet with EngFlow. We might be working towards being able to do something like that, though. So it's not currently possible. I haven't seen any of the remote execution implementation that does that. This is because it's not really part of the protocol itself, and it's not up to the client either. It's really up to the server to say, you have permissions to see this resource or not. And that's something that we have not implemented yet, and also not seen implemented in the wild. But in theory, it is possible, by all means. So the answer is, maybe, at some point. Oh, I mean, you work for Siemens, just reach out to us. Maybe you can convince us to do that.
Thank you for the nice presentation, Antonio. Thanks for mentioning the ray tracer. It's not from me, but it's a very good fit from CMake. My question is, in CMake, you cannot have like a project with multiple target platform in the same build. You need to rerun CMake with a different toolchain file for each of the platform you want to target. On some embedded system, they have like one key processor that is on Linux, on some others that are like microcontrollers, and you would like to build them in one invocation. And I was wondering, is that possible in Bazel, or?
You can specify, like Bazel has multiple kinds of platforms. It's got target and OS platforms, basically. And I think you can, I'm not entirely sure. I would have to look at the docs. I think you can only specify one target platform at a time. So that wouldn't necessarily be possible, I think. But I'd have to check that. I'm not entirely sure.
Okay.
I would suggest contacting the lawyer.
Thanks. I will do so.
So then, thank you very, very much, Antonio, for this nice introduction to Bazel build. Thanks.
Thank you.